Welcome to our SUNSHINE E-infrastructure webinar. I'm going to give a very short introduction to the SUNSHINE project and the infrastructure before my colleagues will provide a much deeper insight into the SUNSHINE tiered safe and sustainable by design approach, how this approach is implemented in the virtual infrastructure, and we'll make a very short demonstration of the infrastructure in one of our key SUNSHINE case studies, which will also be presented. In the SUNSHINE project, leading research and technology organizations are cooperating on a daily basis with industrial partners to develop and implement safe and sustainable by design strategies for advanced materials, and more specifically to a category of advanced materials, the so-called multi-component nanomaterials. There is not a formal definition of what multi-component nanomaterials means, but we have a working description in our project. We describe them as advanced materials formed by two or more functional components at the nanoscale, or by a nanomaterial with a unique chemical composition modified by hard or soft coatings. So these advanced materials are in fact nanocomposite materials. In the SUNSHINE project, we have 34 partners from 12 European countries and from United States, China, South Korea, and South Africa. So we are a truly global project with partners also outside of Europe. Our advisory board includes leading experts from regulation and academia from Canada, United States, and Europe. The SUNSHINE concept combines the bottom-up generation of essential knowledge, data, and tools to assess the safety, functionality, and sustainability of the multi-component nanomaterials, with their top-down integration in our digital e-infrastructure. The SUNSHINE E-infrastructure is a digital platform based on the safe and sustainable innovation approach, which was originally introduced in the NanoRec 2 project, but then further developed at OECD level. To operationalize the safe and sustainable innovation approach, we're combining a comprehensive tiered methodology for safe and sustainable by design assessment and decision making with a trusted environment between industry and regulators and resources to support regulatory preparedness. The SUNSHINE infrastructure is designed to facilitate collaboration and exchange of information between supply chain actors to promote development and implementation of safe and sustainable by design strategies for advanced materials in general, with specific case studies targeting multi-component nanomaterials. The system also supports SMEs and large industries in selecting and applying simple and cost-effective experimental and modeling approaches to acquire the data needed to test the effectiveness of the safe and sustainable by design strategies. We also have a special focus on grouping and read-across approaches to enable the use of existing information for SSbD decision making. The infrastructure also includes algorithms to assess the risk-benefit balance of the modified materials and products at each stage of the innovation process. This is to make sure that they are safe and sustainable, but also that the modifications have not compromised their technological functionality or economic viability. The infrastructure is a user-friendly digital hub, which is inclusive in the sense that we've always tried to develop it by engaging key stakeholders in all steps of development and implementation. The infrastructure will also enable controlled exchange of information between supply chain actors by means of highly innovative blockchain technology. It includes a tiered approach to assess safety, functionality, and sustainability of the advanced materials and related products at each gate of the agile stage gate innovation process to inform go-to-development and go-to-market business decisions. The infrastructure is state-of-the-art as it's based on the latest knowledge and data on the environmental and health implications and the functionality of the multi-component nanomaterials. It is open and fair as it provides access to the SUNSHINE open and fair database. It will also include guidance on how to cost-effectively generate new data for developing and validating safe and sustainable by design strategies. The system includes methods for grouping and read across for SSbD purposes. The prototype of the infrastructure is already available, and we are now testing it in real supply chain case studies provided by our industry partners. One of these case studies was provided by the company Laurentia. It involves a novel fast-free anti-sticking coating used in the bakery industry. This case study will be introduced in more detail in the presentation of Magda Blossi from CNR Istec, who is the lead for this case study in the project, while the tiered approach for safety and sustainability assessment will be presented by Elisa Pizzol from Green Decision, and the infrastructure will be demonstrated by Alex Zabel from Green Decision. With this, I thank you for your attention, and I kindly invite Lisa to tell us more about the SUNSHINE Safe and Sustainable by Design approach.
Thank you, Daniel. Good morning to everybody. I'm trying now to share my screen. So I'm going to introduce the SUNSHINE SSbD approach that is at the basis of the SUNSHINE E-infrastructure. The policy context, the policy framework that requires the development of SSbD approaches and tools is composed by the European Green Deal, the Chemical Strategy for Sustainability, the European Commission recommendation for establishing a European assessment framework for safe and sustainable by design chemicals and materials, and specifically this recommendation is asking for a tiered approach to safety and sustainability, which covers all the different steps of product development, but that is it's requiring also to develop tools and methods that cover the early stage of innovation. Why a tiered approach? Because as we know, at the beginning, in the initial stages of product material development, we have a low availability of data, these data are usually in a qualitative form, and the uncertainty in the assessment is quite high. When the process of product or material development is moving on, then more data are available. We have additional quantitative data that allow us to bring the assessment from a qualitative to a quantitative form. As already said, the main goal of SUNSHINE is to develop the infrastructure and to facilitate the development and implementation of SSbD strategies for product enabled by advanced multi-component nanomaterials. These strategies can be considered as action plans that are designed to solve or mitigate hotspots that are identified by the application of an integrated tiered approach that assesses safety and sustainability aspects. In this presentation, I will describe this integrated SSbD approach. The SUNSHINE SSbD approach is composed of is assessing safety and sustainability aspect at different stages of product development. It is composed of two tiers. The first tier, it is a screening level qualitative approach that can be used in the initial stage of product development when information are available mainly in a qualitative form. Those alternatives or those materials that can pass the first tier are further assessed in tier 2, that is a quantitative assessment method that is addressed for the later stage of innovation. As you can see, if we follow the agile stage gate model, we can locate tier 1 in the initial stage of development between gate 1 and gate 3, and tier 2 from gate 3 to the post-launch, even if there is some flexibility in this assessment. For each tier, we are evaluating different aspects along the life cycle stages of the material or product development, starting from the raw material and resources acquisition, the production of the multi-component nanomaterial, the production of the product that is incorporating the multi-component material, the use of the product, and the end of life. Specifically, if we go into the characteristic of tier 1, it consists of a self-assessment questionnaire for pre-evaluation of safety, sustainability, and functionality, and it can be applied to assess possible different design alternatives and identify potential safety and sustainability hotspots of concern, along with information gaps and regulatory needs. And this can be applied already in the early stage of innovation at low TRL. Tier 1 is composed of different parts. The first part is an introduction section with the aim and scope of the questionnaire. Part 2 and 3 collect general information on the product, on the material and on the product, and this information can help the further interpretation of the results that are coming from the part 4, that is the core of the tier 1, and it is composed of a set of questions. Up to now, we have 153 questions that are divided into 5 sections that represent the different life cycle stages. And within each life cycle stages, questions are divided according to safety, sustainability, and functionality aspects. Here you can find the infrastructure page that include the tier 1 questionnaire, and as you can see, you have the different life cycle stages: raw material acquisition, production of the product, incorporating the multi-component nanomaterial, and so on. And for each of these life cycle stages, questions are divided according to functionality, safety, environmental sustainability, social sustainability, economic sustainability. For each question, there are different possible answers: yes, no, I don't know, not applicable. And for each question, then yes and no can positively or negatively contribute to safety or sustainability aspect. For example, if we consider the question, are critical material used? Yes is negatively contributing to sustainability, while no is positively. On the other hand, if we have the question, do you use renewable raw materials? Yes is positively contributing to SSbD performances, while no is negatively. Here in the scheme, you can see that you have two different colors. The red questions are marked if the yes means that the yes answer means negative impact to sustainability, to safety and sustainability, and the green answers are those where yes means positive impact to sustainability. The assessment is a comparative assessment. It means that our innovative material is compared with a benchmark, where a benchmark is a material already on the market that has the same function than the material that we are assessing. And in any case, the assessment is how much a material is better than the benchmark. On the right side, you can see the result of this specific stage, life cycle stage and aspect, safety, where you can see that the innovative material has a higher sustainability, safety in this case, performance than the benchmark. And you can also say that for the innovative material, you have the blue and light blue, where blue are those questions that are replied with yes or no, while the light blue are those questions that are replied with I don't know. And in this case, it means that that part is uncertainty. There is a specific uncertainty assessment within the methodology that will be further described by Alex Zabeo in the next presentation. Tier 1 allows to visualize the result on 3 levels. It can identify product performances according to life cycle stages, product performance according to aspect, technological functionality, safety, environmental, social and economic sustainability, and as a comprehensive SSbD performance that integrates all the questions along all the life cycle stages and the different aspects. The visualization of this result will be presented later on in the application of the case study. The infrastructures allow also to visualize the comprehensive result of the material according to the different aspects in a very structured way, where you can see in this case that the innovative material is performing better than the benchmark for all the different assessed aspects. This is because it is green. Those alternatives that present good performances for Tier 1 can be then further developed and further assessed within Tier 2. Tier 2 consists of regulatory risk assessment, life cycle assessment, life cycle costing, and social LCA methodologies. And it is a quantitative assessment that can be performed when available information can be collected in the later stage of development. This is just to sum up a little bit the relationship between Tier 1 and Tier 2. The main aspects that are assessed within Tier 1 is the comparison of the innovative alternative material with a benchmark that we have seen that it could be another material with the same functionality already in the market, or it can be compared with another alternative with the same functionality. Tier 1 can answer to the question if the innovative alternative is better than the benchmark. In the case of positive answer, this alternative can be further developed and then further assessed in Tier 2. If the answer is no, the suggestion is to consider to stop its development. In Tier 1, we can have also a comparison between different design alternatives, and the aim in this case is to select those alternatives that have the highest sustainability and safety performance for further development. Both in the case of the comparison of the innovative material with the benchmark or the comparison between different alternatives, Tier 1 can support the identification of sustainability, safety and sustainability hotspot of concern that need to be further assessed during the later development stages and then in Tier 2. As far as Tier 2 is concerned, it follows the 5 steps of the GRC SSbD framework, where step 1 to 3 are steps that are not comparative because we have the intrinsic properties of the material and risk assessment, occupational and say consumer risk assessment that are absolute methodologies, while for step 4 and step 5, since it is related to sustainability assessment, these are comparative methods that assess the innovative alternative against the benchmark. In case of step 4 and step 5, we have 2 possibilities. The first one is that the innovative alternative is compared only against the benchmark to see if it is if it has highest sustainability and safety sustainability performances, or we can have different innovative alternatives that are both compared with the benchmark, and then the result of this comparison is compared in order to identify which alternative is better to further develop. The final aim of Tier 2 is to provide a SSbD performance of the assessed alternatives, what is called SSbD levels within the GRC framework. And now I will give the floor to Magda Blosi, who will present the case study, the characteristic of the materials of the case studies, and then I will come back with the presentation of the result of Tier 1 and Tier 2 applied to the Laurentia materials.
Okay. Good morning. I'm Magda Blosi from CNR. I'm the case study lead for Laurentia case study that deals with anti-stick coatings for aluminum molds for the bakery field. Currently, the most used anti-stick coating for this field is Teflon, a PTFE polymer. That suffers of some concerns and problems in terms of durability, costs, and safety, because being a PFAS-based material, European Commission is posing some limits in the temperature usage in order to prevent the release of PFAS compounds in the environment, and also imposing a frequent recoating of the molds, making the use of this polymer very expensive for the company. Laurentia company proposed to overcome these problems, proposed a safety by design multi-component nanomaterial alternative based on silica carbide core and titanium shell. And this material has been selected also due to the very good anti-stick properties that are able to provide. Also because the silica carbide has very good thermal properties, able to improve the cooking cycles at low temperature and to improve the durability of the coating. Titanium shell is added in order to improve the compatibility of the silica carbide into the silicone paint, that is the paint applied on the aluminum trays. I reported here the process flow diagram of for the production of the material in the Laurentia company. It starts from a wet synthesis by salt gel of the nanoparticles that are heated at 400 degrees in order to achieve a nanopowder that is embedded into silicone paint formulation, sprayed on the aluminum trays that are finally cured at 200 degrees in order to achieve the coated aluminum trays, our nano-enabled products. As first, we identified the main hotspot exposure scenarios, identified at the inhalation hotspot for the worker exposure during the processing, and the ingestion related to the use stage due to the food contact material. We proceeded by characterizing the material in the case study in a life cycle stage approach characterization, addressing safety, functionality, and sustainability. The safety has been addressed by characterizing the multi-component nanomaterial in terms of powder, so the powder coming from the heating treatment from the stage 2. Physicochemical data have been gathered of this nanomaterial. The ecotoxicological properties have been defined, and also exposure assessment have been performed by exposure monitoring campaign by Tene during the processing. Also, we focused on the functionality, so characterizing the non-enabled products, so the coated trays, by assessing the functionality, the durability, and the release into simulant food media. And also the whole life cycle have been considered by assessing and implementing the life cycle assessment and the material flow analysis. I reported here some summary physicochemical characterization that we performed on the nanomaterial. We assessed the composition, the crystalline phase, the morphology. We used a widespread characterization technique to characterize this material. The final coating is a result of two sizes of particles, 60 nanometer and 500 nanometers, that combined together are able to give the optimal and hydrophobic properties. We developed a safe and sustainable by design approach for this case study. We have the baseline material that is the Teflon-based coating that suffers of the problem that I explained before. The tier 1 safety by design alternative is the material proposed by Laurentia with the silica carbide core and the titanium shell. Due to potential rust production from titania and to EFSA concern about the using of titania for food contact material, we developed a second safety by design alternative replacing titanium shell with the silica shell. We selected the amorphous silica because it's an inert material, and also it can be easily prepared by salt gel, and it's also very compatible with the silicon carbide core. We developed this material and we prepared this synthesis at lab scale in CNR. The synthesis has been transferred to Laurentia that upscaled the synthesis and prepared the material, incorporating into the coating and distributing this material to all the consortium. All the activity of the different work packages of the project have been developed addressing safety, functionality, and sustainability for the different life cycle stages, and comparing tier 1 with the titanium shell, tier 1 material, and tier 2 material with the silica shell. I reported here some functional results assessed by Laurentia, comparing the two alternatives, tier 1 and tier 2, once embedded into the coating, and both materials show very good functionality with very good anti-stick properties, both on the fresh coating, but also under, after abrasion cycles. So, okay. I reported here the results of genotoxicity testing performed by Swansea University. No relevant concerns regarding the genotoxicity have been assessed for both the material tested in the both sizes, 60 nanometer and 500 nanometer. RIVM tested the inflammasome activation, the inflammasome potential of the material, also comparing them with the single components, silicon carbide and titanium dioxide. The results showed that the presence of silicon carbide increased the inflammasome potential, particularly for the 60 nanometer particles. The presence of silica shell seems to increase the inflammasome activation, and further data now are ongoing to be collected with new endpoints in order to better define the safety profile of all the materials of the case study. We also, focusing on the use stage, we also tested the migration test in food simulants in agreement with the European regulation for food contact materials. We exposed to food simulants fresh coating and a braided coating, comparing tier 1 material with the titanium shell and tier 2 material with the silica shell, compared with the control that is a coating without nanoparticles. All the results show that both the material are very lower than the limit allowed for the regulation. And also the data showed that the presence of nanoparticles in the coating mitigate the release in general of different metals also from the aluminum molds. I reported here a scheme of the material flow diagram prepared by EMPA on silica carbide titanium shell, and it was performed to assess the distribution and to predict the distribution of the nanomaterial in technical and environmental sinks. The goal is to develop a predictive model for the environmental release of the multi-component nanomaterial along the life cycle from production, manufacturing, and use to the end of life, and also a loss rate of the material has been assessed comparing tier 1, the silica carbide titanium shell, with tier 2, silica carbide with the silica shell. And the result of loss rate balance showed that manufacturing the tier 2 material with the silica shell demonstrated a reduced loss rate corresponding to a decrease in the environmental concentration levels. Also, the life cycle assessment has been implemented as with the tiered approach explained by Lisa. And in the first stage, comparing our baseline Teflon with tier 1 silica carbide titanium, and after the Tier 1 and Tier 2 qualitative and quantitative tests, the results showed that in general the material proposed by Laurentia, so the Tier 1, showed an overall improvement in environmental impact with respect to the Teflon coating. Then also the Tier 1 material titanium shell has been compared in terms of life cycle assessment to the Tier 2, the silica coating material, and the results showed that the Tier 2 has reduced impacts both in the environmental and the economical aspects. Concluding, we developed and implemented a safe and sustainable by design strategy for the multi-component nanomaterial. Due to safety by design alternative have been produced and distributed: silicon carbide core titanium shell and silicon carbide core silica shell. The data, a widespread set of data has been gathered along the process flow, covering a three-dimensional domain: safety, functionality, sustainability, for both the safety and sustainable by design alternatives produced. Laurentia has implemented the use of the silica carbide titania in real bakery user condition, and is also very interested in the development of the Tier 2 material, the one with the silica coating, due to the lower environmental impact and lower cost. New experiments and new toxicological endpoints are going to better define the safety profile of Tier 1 and Tier 2. Thank you for your kind attention.
I hope you can see my screen now. Okay, I will follow Magda with some detailed result of the application of Tier 1 and Tier 2 to the two materials developed by Laurentia. Coming back to the previous scheme, in Tier 1, I will present the SiC-TO2 compared against Teflon, and then in Tier 2, since there is an additional alternative that seems to have better performances, we compared SiC-TO2 and SiC-CO2, following the 5 steps of the GRC framework. So, I'm sorry. Okay, good. So Tier 1 application. Tier 1 application show that the innovative material performs better than the Teflon, the benchmark, for all the different life cycle stage, with the exception of the end-of-life treatment, which show a lower performance in comparison with the benchmark. Here you can see in blue the innovative material, and in light blue the uncertainty related with the evaluation of the innovative material, in gray the benchmark, and in light gray the uncertainty related with the benchmark. On the right side, you can see the probability that the innovative material is better or equal to the benchmark. And as you can see, for all the different life cycle stages, with the only exception of the end of life, you can see that the innovative material is performing better or equal to the benchmark. A similar result is also proposed for the different aspects, such as safety, environmental sustainability, social sustainability, economic sustainability, and functionality. In this case, according to the result, the probability that the innovative material is better or equal to the benchmark is 100% for all the different aspects. Then the Tier 1 applied to the Laurentia case study showed that from integrating all the different questions related to all the different life cycle stages and all the different aspects, show that the innovative material has higher safety and sustainability performances than the benchmark. And in this case, the probability that the innovative material is better or equal to the benchmark is 100%. Here we can see the window where the infrastructure is showing that for the innovative material, SIC-TO2, this is performing better than the benchmark for all the different aspects. As a conclusion of this assessment, we can say that the innovative material is performing better than the benchmark for all the different aspects and life cycle stages, and that we have one concern, one point of attention that is represented by the end of life stage that needs further assessment. And for this reason, we apply a full life cycle assessment and all the 5 steps of the GRC framework to assess the SIC-TO2, but also SIC-CO2, that is the second alternative that has been presented before by Magda, and is a further development of this coating that will be further assessed within Laurentia. Also in this case, for tier 2, we are following the 5 steps of the GRC framework, and we are applying step 1 to step 3 to both material, since these 3 steps are not comparative. And then step 4 and step 5, these are a comparative assessment, and both material are compared against the benchmark. And then the result of this comparison is compared in order to evaluate which of the 2 alternatives perform better. I'm not going to show you all the results for the 2 materials. Now I will follow SIC-TO2, and then at the end you will have the comparison with the SIC-CO2. So in the case of SIC-TO2, we have that for step 1, that is hazard assessment of the chemical material, the material is performing quite well, in the sense that the score for each aspect of step 1 is 4. The GRC framework has a scale of score from 1 to 5, where 1 to is the lowest score, and 3, 4, 5 are the highest score when there is the cutoff is passed. And you can further develop and assess the material. So in this case, the material is performing quite well with a score of 4. Going on with the GRC framework, the step 2 is related to human health and safety aspect in the chemical material production and processing phase. And in this case, we applied regulatory risk assessment. Here you can see the distribution of the risk characterization ratio for one specific exposure scenario, that is occupational inhalation. As you can see, the value of the risk characterization ratio is well below 1, thus allowing to say that there is no significant risk for this material in the occupational setting for this specific scenario. In case of step 3 of the GRC framework, we have human health and environmental aspect in the final application phase. Here you have a different visualization of the risk characterization ratio. First, you have a histogram visualization. This is a curve of a probabilistic distribution of the risk characterization ratio. In this case, in the use phase, we assess the ingestion of possible release material from the tray. And as you can see, the result is far below 1. meaning that there is no relevant risk associated with ingestion of food that has been cooked within the assessed tray. In the case of step 4 and step 5, a life cycle assessment has been performed, a social life cycle assessment and life cycle costing for both the materials, for SiC TO2 and for SiC CO2. And here there is the result that are included in the infrastructure, where you can see that the innovative material, SiC TO2, is performing better in all the assessed impact categories in comparison with the benchmark. On the right side, you can have the radar visualization of the same result. In the case of social LCA, you can see that the innovative material is performing better than the benchmark, and you have both the visualization as histogram and as radar. In the case of the life cycle costing, there are some aspects in the case of the cost that are not completely in favor of the innovative material, but as a complex life cycle costing, we can say that the innovative material perform better from economic point of view than the innovative material, than the benchmark. And finally, the infrastructure allows you to visualize the comparison of the different steps of the GRC framework, both for the two, for SiC TO2 and for SiC CO2, for both alternatives. In this case, we can see that SiC TO2, that the SiC CO2 is performing better than SiC TO2, especially for social and economic sustainability, because the blue, light blue color is a higher category in terms of SSbD performance than the green. As a conclusion, we can see that the combination of Tier 1 and Tier 2 has demonstrated its added value in guiding early stage of innovation, especially Tier 1 can be applied at the beginning of the development process, where the valuable information is limited and it is not possible to perform a full risk assessment, life cycle assessment, and so on. The tiered approach enables companies to assess their sustainability performance in an easy and affordable manner, which can make them more competitive in the market while leading the design of more environmentally friendly nanotechnology of high social and economic benefit. There are also some future research needs. For example, we are in the process of improving Tier 1 to select key aspects that need to be always assessed. Indeed, we have 153 questions that are a huge number in the case you have a higher number of alternatives to evaluate in a screening phase. So we are working to select a lower number of very relevant aspects that need to be always assessed. The integration of the result provided by the different steps of the GRC framework should also be further assessed and improved. We have some suggestions in this direction that we will further present. And then the application of LCA to the materials identified that there is still a lack of specific characterization factors for nanomaterials, which needs to be further developed. So thank you very much for your attention, and I will leave the floor to Alex Zabel, who will present the infrastructure.
Thank you, Lisa. I'm Alex Zabeo. I'm the Chief Technology Officer of Green Decision, the main developers of the SUNSHINE E-infrastructure that we are seeing today. So just a brief presentation, and then we can see the E-infrastructure in action. So, as you already understood, the main aims of the Safe and Sustainable by Design E-infrastructure is to facilitate interaction and information sharing. So different supply chain actors can share information in a safe environment and provide their data related to the different stages of creation of a new material or of a new product, embedding the new material. Then it also supports industry in acquiring the data that is needed to properly evaluate safe and sustainable by design strategies. And also it allows to evaluate safety and functionality and sustainability at all the different stages, so that we can take informed decision whether to move to the sequent stage and which alternatives. So we can have different alternative developments that we can decide upon and choose which one should move from one stage to the other. So this is created in such a way that companies can assess their products before going to the market and try to have a good compromise between safety and sustainability and also functionality without losing functionality, so that they can aim at economical success, avoiding risks. So the methodology that is implemented in the infrastructure is basically based on this division in tiers. So the stages of the stage gate process are aggregated into tiers. We have models and methodologies for tier 1 and for tier 2. In tier 1, the information is qualitative. It's mainly a questionnaire. While in tier 2 is much more detailed. There is quantitative information for all the different steps of the JRC framework, safe and sustainability by design assessment. So this is something that is already in line with different requirements, for example, for REACH, and it's also based on life cycle assessment, life cycle costing, and social life cycle analysis. So it's more complex to perform, but of course gives more detailed results about our product and about our nanoparticles. So the infrastructure itself, it's a big tool that is collecting also tools coming from previous experiences and in some cases external data sources. So this is built on top of other experienced tools and projects. It is basically providing information and tools to work on related to the data part, to the models part, where I can perform, extract new data or evaluate the results. And then there is the biggest part, which is related to the assessment of the different levels and the different details. So it's a complex infrastructure that is aggregating different type of tools and software. We will see it in action in a few seconds, but anyway, each of the tools included in the infrastructure always provide a dashboard. Of course, there is the main dashboard, which Lisa already demonstrated, but anyways, this gives in a glimpse an idea of the results that you can obtain and on the status of your project. And it's shared among all the users working on the same project. And then for each tool included in the infrastructure, you always have detailed results in different charts and tables. And these results are then brought back into the main infrastructure to get a final evaluation or assessment of the different alternatives and compare which one is better under the safe and sustainable by design assessment framework. All this is also related to the SUNSHINE database, which is an open and fair database, which provide not only data to the users, but also a RESTful API, which means it's open for other tools to register and collect data from the SUNSHINE database. This data can be extracted in different formats, but was mainly built for working with the models, because this is the main aim of the infrastructure, is allowing users to generate data starting from models and generate new results. So starting from this database, we can import data and then use this for different assessments. The API provides different type of data and can be, again, used by several external applications. It is currently not publicly available, as the project is still ongoing, so we cannot share the data, and we can only share publicly available data as of now, but the API has been kept private to the project partners as of now, so you won't be able to use it. Finally, a brief introduction on the technical aspects of the infrastructure. It is, as you can see from this figure, it is a complex interaction of several tools which are managed and orchestrated by the Amplify tool provided by AWS. Amazon AWS, it's a serverless development infrastructure where instead of having a single servers providing all the needed tools for the infrastructure to work, there are several requests to different services provided by AWS. This makes the development more stable, reliable, and scalable. So when you need more power to perform your assessments, AWS will provide automatically, and this is much more manageable than having a single server. As far as tools that we've been using, the software is built on top of the React framework. It's using a Node server, and as you can see, we have different type of databases that are used, and very complex interaction among these tools that I know it's not the focus of this presentation. So this is it as far as initial presentation. We can move on to the tool itself. So this is the landing page of the infrastructure tool. You can see it's the logo of the company and our claim. You can enter the tool from here, but before entering, you can also check some generic information about the tool, and especially about the sustainable innovation approach, which I think Leah can guide us to. Leah, are you there?
Yes, I'm just trying to get the camera on. Yes, thank you.
Great.
Okay, so thank you. So I'll tell you, so today in SUNSHINE, we don't only talk about safe and sustainable by design. So we really talk about SIA, which is the safe and sustainable innovation approach. And the picture that you see is from the OECD, which really explains this idea of this combined effort where innovators are really more into applying safe and sustainable by design, but there's also a role for regulators, and that is regulatory preparedness. And this is facilitated by this early dialogue that is so important, and you'll see it in the modules that we want to implement in the E-infrastructure for anticipation and preparedness. So what we have is that, like I said, SSbD, for those of you who, just for a recap, is this integration of safety and sustainability in innovation. And this is done in an iterative way throughout the entire life cycle. Regulatory preparedness is this anticipatory action where it allows regulators to be at the forefront, to be proactive, so that we can adapt to regulations and take actions accordingly. And this is really facilitated if, as regulators, we know what is happening early in the innovation. This early dialogue in a trusted environment really is the key aspect. And we'll hear from TEMASOL today about their foresight. Like, you need to understand what is happening early in the innovation process. So I think for me, that's just a recap. When we go to the E-infrastructure, I'll go in a little bit more detail on the trusted environment, but as you can see, you have, this is the E-infrastructure, and what we'll see is what was presented today was more on the safe and sustainable innovation approach, and what I'll present and with TEMA solution, we'll also have this, prototype for the module for preparedness. Okay, I'll take it back to you, Alex.
Thank you, Leah. So this is something that the user can find before creating a user and logging into the tool. So it's always available to everyone, and it is an introduction of all the different aspects. Then if we click the enter button, we can, of course, register with a new user or just log in if we have an account. Of course, I have mine. So once we log in, for the first time, we are welcomed with this introductory page explaining the stage gate process, the tiers, and all the different stakeholders who can access the tool. We can decide not to see this again, but we can then reactivate this introductory page on a later stage. Once we close the introductory page, we are brought to the initial page of the infrastructure tool, which is divided in two parts, the featured apps and the personal and shared projects. So in featured apps, we have a selection of the main applications that are included in the infrastructure and that are available from the project part. So you create a project when you want to evaluate a case study and follow all the steps of the procedure using the different tools. But of course, from the featured apps part, you can also jump directly to a single model that you need to use or to the database. So this is where you decide if you want to do a very fast assessment for a specific thing, or if you want to go to the complete assessment for a specific project. Of course, you can create how many projects you want and do this for the different materials that you have. In this case, we have a project here which is related to the Laurentia case study, which has been presented by Lisa and Magda in the previous presentations. So let's open this one. What we have here is, like I was introducing you before, and the dashboard page. We have lots of information in this page. So we have here an idea of the stage and tier we are working in this moment with our product. In this case, because this is a case study which is basically complete, at least until the stage 3, we can see that we are starting directly. So we are brought to the latest stage that we have. But of course, we can always see results related to tier 1. So this first box is giving us information about where we are in the stage gate process. In the second box, we can see which kind of supply chain actors are involved in this project. They can be suppliers, manufacturers, distributors, or retailers, and the progress of data inclusion in the project. In this case, we have a complete assessment, so we have reached 100% progress. In the bottom part, we have this assessment matrix where we can see results for the different alternatives according to the different steps of the JRC framework. We have here 6 steps because step 5 has been divided in 2 parts, one specific for social and one for the economic, while in the JRC framework, these 2 are brought together. Finally, in the bottom part of the dashboard, we can see that we can share our project with different colleagues inside our company or from other companies, which can, of course, be related to different supply chain actors. The users that you share your project with can be just viewers, editors, or administrators. Finally, you can share comments about the work that is progressing in the infrastructure, so that when other users open the dashboard page, they can always see what's happening lately in the assessment. And so this is a means of communication related to the project. So let me switch to tier 1. We can see that for this case study, we started with the idea of substituting the benchmark, which was the Teflon, with this new material, which is SIG TO2. So initially, in stage 1, tier 1, we were only assessing TO2 in order to understand if it should move to the next stage of assessment. To perform any assessment, we need to use this left-hand menu. You can see it's divided in tier 1 and tier 2. This is because I am in tier 2, so I can perform both assessments. If we are in tier 1, we are only allowed to perform tier 1 assessment. Each tier is divided in several stages. Tier 1 is more simplified, so it only has 2 stages, which are including all of the aspects evaluated in the JRC framework. So moving to the screening part, let's say, we can see we only have one tool available, which is the questionnaire, and we only have one alternative, which is the SIG TO2, as introduced by Lisa. So when clicking on this alternative, the corresponding tool is opening. You can see that it's shared among the same people, it's being completed, it's related to the Laurentia project, and you can see on the left side that the menu has changed because it's now related to the application for the tier 1 questionnaire. The questionnaire is divided in different aspects, functionality, safety, environmental, social, and in each aspect, as Lisa was introducing, we have different life cycle stages, and we can answer to yes, no, I don't know, not applicable questions related to our alternative compared to a benchmark. So this can be done for all the different aspects and all the different life cycle stages. While we input the results, we can see the specific result chart is updated live. And then we have also a results page, which is including results from all the information that has been provided. As we are dealing with uncertain information because of the I don't know answers, you can see we have a part that is, let's say, sure. So the answers that are saying that we have a positive impact the sustainability, to safety and sustainability, and the part that is uncertain. And in the uncertain part, we have reported a violin plot, giving an idea of the probabilities for that result. And then on the right side, we can see, like in this case, the TO2 is 100% probably better than the benchmark, and this is already visible from here. Then we can see the same results divided by aspects or by life cycle stages. So this is what tier 1 can provide. The results from its application are reported in the dashboard in tier 1. So as we have seen there, we are always, even with the uncertainty that we have for tier 1, we are sure that the SIG TO2 alternative is better than the benchmark that has been selected. So this is something that allows us to do this assessment, but we can also evaluate regulatory preparedness. So this involves 2 types of assessments that are related. the application of the trusted environment, and the foresight framework. And here, again, it works like before. So when I click on the alternative, I am brought to the specific tool that I let Leah introduce to you as far as the trusted environment.
Yeah, thank you. So the regulatory preparedness really has two components. So this first one is really just focused on a module to build a trusted environment. And what we have done in collaboration with our work package really is to provide an information map to guide the user on what is a trusted environment, what are the goals for the trusted environment, whether you want to exchange information or you want to co-create solutions, or if you just want to develop safe and sustainable and beneficial innovations, or just create awareness, tips and principles. So really to give a guidance on how to build the trusted environment. And this is very linked to also work on the SIA, because we're also looking at roles and conditions in which innovators and regulators will be able and willing to have a trusted environment. So this information map is really just a guidance. And if you go down, what we've done, if you can scroll down, Alex, we have also translated this into deep a guidance. Oh, do you have the table with the?
I'm sorry, it's been removed.
Oh, okay,
I
no
don't know
problem.
why. I'm really sorry for this, but the table is missing.
It's a prototype, so it's a live. So what we've also done is created a set of questions that can lead you to relevant documents. So for instance, if you're interested in anonymity, then you will probably think of the Chatham rules. If you're thinking about different aspects of confidentiality, data protection, protecting IP, we have also looked at different conditions and different legal conditions for different stakeholders will have. So the idea is to have these questions. So if, for instance, if anonymity is important, then it leads you to a document. If IP is very important for you, then this is the problem. If liability, which is a big one for regulators and innovators, is an important clause, then we are building a guidance and documents that can help you build a trusted environment. And this is sort of a basis if you want to build this sort of dialogue between innovators or regulators, or between regulators and regulators, or between innovators and innovators, because this is such a broad concept. And this really is the basis to the next work that we have, which is the foresight. So we give you first a guidance on how to build this trusted environment among experts, and now my colleagues from Tema Solutions will guide you on how we incorporate this trusted environment in a bigger framework for foresight, so that we can have this anticipatory role and be prepared for upcoming challenges and innovation. So I'll give the floor to our colleagues from Tema Solutions. Yep.
So it's James, I guess.
Yeah, and here I am. And thanks for the really interesting presentation. No, I think it was really good to, just going back a step, to hear about the Laurentia case study from Magda and Lisa, and then to see how you access that through the E-infrastructure. It would be an interesting exercise in the future to compare a new innovative product using the E-infrastructure, and then how it would be done without, and see what the advantages are in terms of savings, time and cost and so on. But the E-infrastructure is a lot more than just a set of tools, as Leah was saying. It's all about including aspects like regulatory preparedness, and you know, it isn't a static thing. It has to grow. It has to take in new ideas all the time. So this this slide but basically carries on from the slides of Leah. Here you see a kind of a cogwheel on the outside, where to make it visually impressive, I put different cogs, and the text, not important. These are just the criteria which will be needed to establish the trusted environment. The trusted environment is like a fortress. So everything that's important goes on inside of that. And we've been working on this foresight framework for sustainable innovation. And the idea is that regulators, policymakers need to have some kind of advanced warning of what's coming along, what's new. And the idea here is that we bring together industry, regulators, policymakers, and other important stakeholders who can work together on information coming out of our studies and pick up early warning signals, weak signals of upcoming trends. And that will give them time perhaps to prepare new regulations on time. It's always been a kind of a standard phrase of ours, keeping up with innovation. Regulators are really trying to keep up. Yeah, so thanks, Alex. Next slide. I'm talking too much. I know. You said 5 minutes, so I've probably taken far too long. Sorry about that. Yeah. So what's going on inside the trusted environment? This is just a very sort of simple little cartoon. A simple cartoon showing how we visualize this process. The idea is that we will have basically two phases where using data mining kind of software, and we'll be discussing with the JRC to use the TIM software. We're going to look at upcoming trends and so on, using the various databases to which TIM is connected. From that, we can distill out the main thoughts which we think are important, give the whole thing to our expert group who can debate and discuss and validate what we're thinking, and then pass that idea on to or back to Leah and her people in terms of looking for new and important trends, so they can be ahead of the field. And the last slide is just really this one is just a simple sketch to show the steps that we're proposing. But basically, this is what I've said. We'll start out with some data mining process, probably in collaboration with JRC, using the TIM software. Pick out the early warning signals, the weak trends, sort them, collate them, get our expert group inside the trusted environment to debate them, and then come up with some sort of short list of, hey guys, this is what you have to be aware of in future. And we're going to do that in practical terms in a pilot study in the coming 2 or 3 months, and we'll hope to have the results of that ready for the final meeting of the project at Lautox in Venice in September. Thanks, Alex. That's it, I think.
Thanks, James. And let's go back then to the tool. So this is something you can always find under the regulatory preparedness area. So then when we move to tier 2, as we say previously, we have the 5 steps of the JRC framework, which are transformed into 6 steps in this case, because of the social and environmental part. So it all starts with the intrinsic hazard assessment. So in intrinsic hazard assessment, we can see we have 2 typologies of models or tools provided. And you can see that one of the 2 have this orange band, which means that the results from this tool only are the ones used to evaluate, to assess this step. Anyways, let's take a look at what we can find in the physical-chemical characterization. This is a tool that allows us to specify information related to our multi-component and the components in it. So it's strictly related to the SUNSHINE database, so that from this interface we can also have an idea of how the database looks like, and data from the database can also be imported in the characterization part. So we can see we have the multi-component and the different components up here that we can select. We can select the different areas of the descriptors we want to include, and then we can the database and the characterization tool are based on a growing supply of information. So we start with just presenting the simple endpoint and the say, and then we can go in more detail, seeing which exactly the different assays. There can be more than one for the same endpoint, of course. So you see that we can always add new experiments with different assays and endpoints. We can establish the conditions. We can have a medium if makes sense. And then we can have different replicates of the data. And all of this is hidden for simplicity in the outside visualization. So with this tool, we can include characterization data in the tool that will be probably used further in the future. But as of now, as I was saying, the results that are used in this first year, which is simplified, among the old tiers is the simplest, is related to this hazard classification questionnaire that follows the guidance of the GRC framework. In this tool, we can again see that we have this separation between most harmful substances, substances of concern, and other hazard classes. And again, it's very similar to the previous tier 1 assessment in the sense that we are just stating if or not our material is falling into these proposed categories for human health, environment, and physical hazards. So answering these questions brings us to this results table that is again following the GRC framework structure. In this case, everything is fine. So this intrinsic hazard part is passed without any problem by both the materials. So what we usually do is then move into production safety and application safety. So these two are very similar because they are related both to safety. Main differences in the production safety, we only have the risk related to this production step, to workers in the production step. The infrastructure provide, again, in this case, several categories of tools. So tools related to hazard assessment, to exposure assessment, and to risk assessment. Each of these tools is available for the two alternatives, and a brief explanation of the capabilities of the tool is provided. Again, as you can see, the orange band is in the risk assessment tool. This is because the results are related mainly to risk. So the previous tools are used to generate information that can then be used in the risk assessment tool. So if we open the risk assessment tool, this brings us to the specific tool interface. So in this case, I have already applied the risk assessment tool and I get directly the results. As you can see in here, I can input the different input data for effect and exposure, and this generates the outputs that we've seen. The output in this case is the risk characterization ratio, which is exposure divided by hazard. So what we are interested in is the probability that this ratio is above 1, because that's the case where we have risk. We can already see from here that there is no probability for this in this specific case study. And also looking at the distribution of the probability, we can see it's always below 0. So this result is brought back into the infrastructure and is providing the value for the production safety. Then, as far as the application safety, it's very similar, but in this case, for this step, we have different targets. So we have the tools related to the occupational, the consumer, and the environmental part. Not all the tools are available inside the infrastructure. Some of them are linked, and so results need to be brought back into the infrastructure. Again, all the tools work in the same way, and the risk characterization tool is the same as before. So if we click, we are again brought directly to this application of the risk assessment tool, which calculates the risk characterization ratio specific to this case, which again, it's always below 0. And we can always view this result in different ways. So as a histogram or as a line chart, providing exactly the same information. So in this case, everything seems to be fine as far as the safety part. And so we move to the sustainability assessment part, which is divided between environmental, social, and economic sustainability. So in the environmental sustainability part, the tool that is used is life cycle assessment. So what we do is collect results for life cycle assessment studies. Let's open the SIC SCO2 alternative, this example. So again, to evaluate life cycle assessment results, we need to have again a benchmark. That's because there is still no way to have an absolute assessment of life cycle assessment results. So we always use a benchmark, and this is also for the social and the economic. So we compare each alternative against the benchmark, and then we compare results of the two alternatives to decide which one is best. So this is done by uploading information related to the LCA that can be produced in different tools like CIMAPRO or OpenLCA. So data can be always import and export in Excel format. Once it's imported, we can assign life cycle stages to the different results that have been calculated. And the tool automatically generates the results chart that is already introduced to you, showing the comparison between the current alternative and the benchmark. This can be seen at the global level, or divided by aspects, or divided by life cycle stages. So these are just different ways of aggregating results. And of course, we get to the JRC-based evaluation table, which associates the different aspects to levels and evaluates if the current solution is better than the benchmark and how much it's better. And according to this percentage of improvement, we get a score that in this case is always the highest possible, and therefore all the levels are passed. The social sustainability assessment is basically similar to the other one. We can see the tool looks the same. The main difference is that we have very different aspects to take into account in this case, that we can still associate to different life cycle stages. The visualization of results is exactly similar to what we had before, but again is specific to social life cycle assessment and gives us again an evaluation table with all the results. And of course, for the economic part, it's again very similar, because again, we are applying the same idea, but as you can see, we have different subdivision in levels, because of course, again, levels are different and specific to the assessment we are performing, but still we are comparing benchmark to the current situation and looking at the percentage of improvement. So all of this information, as we were saying before, and is evaluated in these external tools, and then read by this the SUNSHINE E-infrastructure that is collecting all of the results and used to generate this assessment matrix, which is very simple to look at and give us an idea immediately of the situation among the two different alternatives. But we can always have more information by opening the single tools. If we look at the result page, we can see the chart that has been proposed by the JRC framework. It's a circular chart where we have the different steps and the different levels and the different aspects reproduced in more detail for everything related to the two alternatives. this data we also provide in a more standardized bar chart visualization, and it is available for all the alternatives that we are assessing. And then to conclude, going back to the initial page, just to show you a bit of how the database looks like. But as I was introducing before, and it's very similar to the characterization part. So you can see we have all the different materials presented. Then by opening a material, we see all the different categories of data and descriptors. And by opening a category, we have different endpoints categories and so on. So everything is of increasing detail until you really get to the data. And you can also, of course, upload your information directly in the database. And with this, I conclude this introduction to the E-infrastructure. It's been very brief because we surely cannot go into too much details of everything. And then we would like to proceed with an interaction with you related to this Slido tool, which I don't know if you are aware of. So what we're asking you to do is to please join us at slido.com by including this ID that is related with this presentation today, or you can also use this QR code to be directly brought to Slido. So thank you, someone is already there. And let's wait a bit for everyone to connect. As we can see, as was expected, most of us are researchers in this case, but there's still representatives from industry and regulators. Let's wait a second more. Okay, it looks like the amount is not growing anymore, so I guess we can move on. Now that everyone is logged in, we can move on to the next question. So this is a question related to the type of work that you are performing to understand if you would be using the tool that we are presenting. So is risk assessment part of your daily activities? So it looks like for most of us it is. Great, I think we reached the amount. Let's move on to the next one. Thank you for answering. And that is a sustainability assessment part of your daily activities. So let's check. Okay, so it's the other way around. So most of us are more into risk assessment than sustainability, it looks like. And finally, is taking decision about product development using the agile stage gate process part of daily activities. I guess we will have a big no here because most of us are researchers or modelers or regulators, which means very few of the audience is working on this, probably. Very good. So thank you for answering, and I think I can see it's a very big no answer, but it's okay. So this question is about the tiered approach. Do you think it's a good idea to divide the assessment in these two tiers and the way they are organized? Do you agree? Okay, let's wait a second for the others. Okay. So thank you. Well, it looks like you agree with our proposed tiered approach, so that's good for us. Then this we can skip because none of you said no. So I guess there would be nothing to add to this one. But someone is typing, so maybe we will have something. Let's wait a bit. Oh, we have now 4. Okay. Okay, that's a good idea. So tier 0 is something we already have in mind for the future to add. And this change of name from tier 1, then tier 2, we can think about this if it's unclear, the higher level. So yes, it could be that one sees, but it's more an order in time than a level of precision. So thank you for this. And then is there some additional functionality? So is there any tool you would like to see developed in the system, which is not already there? That you say, oh, why didn't they include this one? I would love to have it, or I need it in my daily activities. In this question, we are talking about tools and models, because there will be another question later on about services, which is a bit different. So let's wait a bit for the other. Durability will depend on application. They need to be further specified in order to properly address this. Okay, so this is usually taken into account in LCA, social and lifecycle costing. When you do the assessment, you always take into account the lifetime of the product and the durability. We can surely think about including all the risk assessment models in the future, as soon as we sign that. Yes, we know that it might seem complicated for SMEs, but we think it's user-friendly enough, and there will be also a guidance in the future, so that the tool explains what I were explaining to you. So we hope that in this way it will be simpler to apply.
In fact, Tier 1 is intended for SMEs, while Tier 2 would be more for consultants. If an SME would need the really complex full SSbD assessment, then the SME would need to work with consultants. Consultants is another important category of stakeholders for this approach.
Thank you, Daniel, for the specification. So now I move on to this new question, and I leave the floor to Diven, that is hosting the second part of the poll.
Yes, hi, thanks, Alex. Thanks a lot. Thanks to everyone for the presentation, and thanks a lot to the audience also in advance for your participation. We would just like to briefly, I know it's close to lunchtime, but if you could hold out a bit more, we would like to ask just a few questions regarding, especially in here, which of the functionalities with your background you would be most interested in when you look at the platform. You know, we have a lot of people from the risk side here. But there seems to be an interest in more or less spread all over. That's good. Shows the necessity of a platform like this to be able to access multiple functionalities in one location especially. Looks to be stable, I think. So perhaps we can move on. Thank you very much for your input here. Then we would like to go into more on the services side. So you've seen the tools, the functionalities, and these tools and functionalities, depending on your background, a variety of services could be offered with the help of the SUNSHINE infrastructure. For instance, one simple one could be just training on the infrastructure or specific tools. So if you could just maybe briefly give us input on which kind of services you would desire from the SUNSHINE infrastructure, or people using the SUNSHINE infrastructure, be it consultants and so on, or also training on specific modules, for instance. Okay, interesting. Alex, we have a chatbot request here.
That's interesting. So video tutorials are something we are already thinking about to add, and trainings, of course.
Yes, yes. And also maybe networking to with relevant experts and consultants.
Yeah, that would be interesting. Yeah.
Yes, so interesting. Okay, support for gatekeepers. Yes, how to embed this information with other aspects of product development. I think this would be quite important, taking into also account trusted environments and foresight. A foresight community. That's an interesting suggestion, yes. I think mainly also to use the platform as a gateway, you know, as a network to connect with experts and consultants in specific areas and availing services in specific areas, be it later stage or early stage, be it in risk, be it in sustainability. I think is quite important, especially for SMEs who have to wear multiple hats. They do need the support. Question to regulators hotline. That's an interesting one. I just don't know about the how one would handle the confidentiality aspects, and so anything that comes from regulators is set in stone in a way. So it's a bit difficult to achieve this. Regulators do have their challenges. I think they know the issues and that are out there, but to come to a consensus and communicating it, it takes time, I think. Regulatory sandboxes, yes. This could be part of foresight, trusted environments.
Yeah, you can already apply the tool, create a new project private to you as a regulator and try things like in a sandbox.
Yeah, exactly.
And this can be connected to the foresight and everything.
And especially also the alternatives, Alex. I think that's really nice
sure.
to have alternatives, so one can see, okay, how does this change the evaluation?
Okay, I think we shall move, otherwise we'll be late.
We have one more. Let's
wait for this last one.
Yeah.
I think it's all.
Yeah, okay. So now just before we move on, so the next question is related to exactly the input that you have given here, and access to the services and functionality to what you have responded. So then we can move on to the next question. There's always this conundrum between, since a lot of effort has gone through public institutions to make certain features or functionalities accessible, or services as well, accessible to innovators, be they young master students, you know, developing a product through their thesis or through a postdoc thesis. And we'll also address that aspect in the next question, but here just to see the readiness level and willingness to pay for services. So I think there's a strong feeling that, especially, for instance, if you also look at SSbD, which addresses the early stages, that their support is needed, subsidies are needed to access the platform and its services. but there is also a majority also willing to pay for these services. Okay, I think we get the idea. We can move on, I think.
Excuse me, we have a hand raised. If you allow one question, because this is our interactive session.
Yes, sure.
Yeah. Oh, actually, I see that now it has disappeared. Yeah, I'm sorry about that. So but just to announce, if you want to jump in and comment, you can raise your hand now, or you can basically unmute yourself and speak, as this is our interactive session. And now I leave you to go on, because the hand that was raising is no longer there.
Yes.
And Stella, sorry, Steven, because there is a question in the chat, so we can already answer that, which is asking access to the infrastructure, but we still cannot provide access until up to now, because it's still a prototype. So there will be a hands-on session in Nanotox in Venice in September, and that's the moment where we provide generic availability to the public. So please, Steven, go on.
Yes. So this is just thanks a lot. So this is just to follow up through from the last question. So we saw that there is a willingness to pay from certain users. From certain users, it's not there, and it's understandable. It's a publicly funded project, publicly funded infrastructure, and also I think many people feel that also early on this support is needed, especially on the researcher side, that they get this holistic support. And here we would just like to see, okay, what are your thoughts on which scenarios you would see that this support is necessary in the current European ecosystem, in the current European environment? So this is also something which does reflect quite a bit the situation where small-scale industry do need support to implement safe and sustainable by design, and Europe is a market full of SMEs and small industries, which are the backbone of the European economy and its innovation ecosystem. So it's quite important that they be able to avail and access these services. So I think we do see a very clear need for this support to be made accessible and available, be it especially for publicly funded institutions and researchers therein, or research or public funded research technical organizations, be it regulators, also state institutions, and small, especially small industries, as well as consultants who are working on public interest projects, and startups and spin-offs as well. Yes, of course. Okay, good. I think
before moving, there is another question. So I'm looking at the chat that is asking what is the difference between this tool and the harmless project tool. Is it meant as a more complex add-on? It is not. These are two projects that have been founded and that are focusing on very similar aims, and are providing two different alternative ways of assessing safety and sustainability. The tools will probably be, we are working to make them interoperable so that we can use both the infrastructure would be able to use tools from the other one. But as of now, they are just two alternative ways users can select to perform the assessment.
And I think I would also like to add maybe the tied approach is quite special to SUNSHINE.
Yes, each project has its own, let's say, detailed way, different way of assessing the thing. Okay, let's move on to the next one.
So yes, are you aware of any other platforms? Now we've talked about Harness, so there is there. So which provide same or similar value, functionality, or information as well. Okay. So I think this also shows that there is also need for an outreach to the community on the work that is ongoing, has been done in these projects. I think we can proceed slowly. I think that's so. If for all of you who have responded with yes, which platforms do come to mind when you're thinking about similar functionality and value? Yes, Harness, of course. Yes. Yes, Suns the if we go back in time, then I think Suns is one of the most important ones.
The workshop is finishing in 44 seconds, so I suggest that this is our last question.
Yes.
I would like to thank the participants very much for the valuable insights and recommendations. We'll take them on board for sure, and we'll try to deliver a much better system by the end of SUNSHINE, even though we would transfer this work to the newly started Sunrise project, which will last for another 4 years. So we'll have plenty of time to make this system much more comprehensive and robust for a real impact on the community. Thank you.